Now it's the turn to see the practical implementation of Exchange specification, the implementation on web services, the .NET Core environment by Jonas Jedeberg.
Yes, thank you, Fabrizio. I'll start with a small presentation. What do we need to build a service? As we've seen earlier today, we need a payload. And for that, you usually create a profile. And you normally need Exchange, but it's optional for pull. And for that as well, you normally create a profile for your specific usage. And you need the WSDL, the Web Service Description Language file for SOAP definition, if you're going to use SOAP. For those, you can download on the website. You find those in different patterns. One small remark, if we're going to do normal or say legacy .NET framework, it's rather straightforward to do SOAP. You can either use ASPX web services or WCF, Windows Communication Foundation, and you have different tools to generate code from your schemas and your WSDL. But we are going to do .NET Core, the new framework, or .NET 5, which is the latest one. I have done it in .NET Core 3.1, but it will work, and I tested it in .NET 5 as well. For SOAP clients is supported in .NET Core since 3.1. Earlier it was not even supported to do SOAP, but it is now in 3.1. But it's not possible or not built in to do a SOAP server. However, SOAP is just XML and HTTP, and for that there is, of course, very good support in .NET Core. And there are external or tools, frameworks that are outside the main framework that solves this. And one of these is SOAP Core, which is an open source project, which is very active. It's updated regularly, and you install this package via NuGet. And I will show you today how to use it. We will generate code, and for that we use tool that Microsoft created, .NET SVC util, which you have to install also via NuGet. And this is actually used to generate the code for a SOAP client, but we will use the same code for a server. So my demo that I'm going to show you, I won't do it step by step, but I have already created this example, and I will go through the main thing, what you have to do to get it working. So we create a SOAP server and an HTTP GET server at the same time, more or less. And we would use Exchange 2020 snapshot pull. We generate code for that, and I would use Visual Studio 2019, as I said, with .NET Core 3.1. And the code for this is available on GitHub at this URL, so you can have a look later on. And just some short information about the profile that I'm going to use. I'm going to show you, but it's a situation publication profile for the payload, and for Exchange I made what I need for a snapshot pull, which isn't that much actually. Now I'm going to show the code. I have created, start with an empty or project .NET Web API, and clean it up a little bit, remove things that shouldn't be there. It's a weather controller or something like that. And then I create some folders. You have a controller. I create a data folder, a model, and a schema folder. And then it's time to generate code. And then I have in a folder, you see here, webinar 5, demo.NET Core schema. I have put the payload schema, which this is the schemas for the payload. So I copy those into this folder, and then I take the Exchange profile, which is Exchange and message container schemas. And then I download the snapshot pull WSDL from the website, the DATEX II website. And I just put them in the same folder. It doesn't change anything in those files. And the selection files here is the profile if you like to look at those. This is the payload and this is the Exchange profile. So put them in the same folder, and then I have a Windows command file, which is this one, which I used to use similar files to this because it's rather long to write all this, and then you can reuse it every time you need to update your schema. I have some parameters here that you could set if you like to have absolute path, but in this case I use relative path to where I execute this, so I have them set to nothing. So you see here that I execute .NET SVC util. I input the WSDL file, and then I have some more parameters. One important one is that the serializer, I like to use XML serializer. You can do data contract serializer as well, but I found this one to be more interoperable. I put the output file, which is the name of it. I put a namespace on the generated code. And then I input all my schemas that I like to use. So it's a rather long list with all the schemas you have in the directory. So this is what we need to execute or to generate the code. So from command prompt, I will execute, and I in the same directory now will have a schema. And I start generating the code. It should look something like this, and in the end it would tell me if it works, and it looks fine. It's finished. And then if you look in the directory, you see that he adds service reference. So because this is a tool to generate the client, they call it a service reference. And this was the one we created now, but he adds new one if you run it several times. So here is our generated file, and it's generated now, more or less. When I've done that, I will copy this file into the solution and put it under the model directory folder. So this is the generated file, which includes now all we need the code to talk to this or do exchange with this SOAP server. I will then change the namespace. So I call this a demo SOAP server .models. And then I do a little trick here. I will, because in the command file, I set that the namespace should be DATEX II. So DATEX II is then used in several places in this file. And it could be rather tedious to rename this every time. So then I do this. I use the using statement to using DATEX II equals demo server models. This actually creates like an alias. So DATEX II means it will be the same namespace. And what do we have more in this file? Well, it's a long file with all classes you need from your profile and your exchange. So here you have traffic element, situation, and so on. Things that we know from classes in the UML model. And we also have one very useful thing here. In the beginning, we have an interface. And this is from the WSDL file, more or less the contract that is used to do exchange with this service. So we have one, because it's pull, we have one method, pull snapshot data in it. We also see the message container class here. And here I have done one more manually added thing to this file. I added an XML root element by doing this. This is not created when you do generate the code because it's needed. But I like to do serialization between an XML document and the objects. And if I have that requirement, you need to add this root element definition. So what more? Well, you will see now, if you have a new project, you got a lot of errors because it uses attributes here, service contract attribute, for example. These are defined in NuGet package as well. So we need to add a package. We need to have this system service model so that it can understand these attributes. So to add those, all NuGet packages, you go into manage NuGet packages. And you see install, and I have these two. We have this service model, and I have the SOAP core, which we are going to use to handle SOAP middleware. And in browse, you can search for a lot of packages with NuGet, of course. But this only needs two. So you have to install those. So then we have SOAP core and everything in place. We have all the framework and libraries we need. The next step is to go to situation publication service. I will add a class to this, and I put it in the controllers. You could put it everywhere, but I found this will be the class and the object that handles all requests for my SOAP service. So this one, of course, I need to implement the interface, the snapshot pull interface. So I inherit from that. And that makes that I have to implement the methods like pull snapshot data. So I won't go through the details of the implementation now, but that is what we need to configure the framework. Because now we have a class that can handle the requests. Then we need to configure SOAP core so that it will use this class as an endpoint. So then we go into startup.cs, which is, most of the code here is from the template, the project template, a normal standard .NET Web API. But I have to initialize a few things. And in .NET Core, there is a built-in IOC container that is heavily used. And I won't go into detail about that, but what I do in this configure services method is that I would add a service and add scoped. So I will add my class that I just created with this interface, snapshot pull interface. So this is now handled in the container. And then I would add this method, services add SOAP core, which initialize the SOAP core middleware. So that's all there. And then in the next method, it normally looks like this. And then I have added these few things. And the main thing we're going to do here is this line. We're going to add SOAP endpoint. And I tell that this endpoint should be of the class of the interface, snapshot pull interface. And then I would tell that it's the endpoint that I would like to use. So I can put in anything here if I like. So I will call this situation service. And I have some binding information, which I added for, this is good for compatibility with Java, for example. If you're using .NET Core, you don't, or .NET, you don't need this, but it has some byte order mark to do, so which Java frameworks will complain if you don't use this one, or don't use the byte order mark, you could say. And the next thing is also important, that we're going to use the XML serializer here as well, so it matches with the code that I have generated. And then we have one more thing at the end, that's settings. You can use SOAP Core in two different ways. Normally, SOAP Core can, from your generated file, generate a WSDL for your contract that you have implemented. Unfortunately, that is not working with SOAP Core currently. It messes up the namespace in some way, so it doesn't look, at least not as I like it to be. But then you have the feature to use your original or external, you can call it, WSDL and schemas. So what I have done is that in the schema folder here, I copied my payload schema and my exchange schema and my snapshot pull WSDL file. So I'm going to use these ones. So they would look exactly as the ones that we generate the code from. And I do this via settings here. So I will load settings from a configuration file, which we have here. So in this file WSDL, this is where I configure to use this external schemas and WSDL. And you can have more than one here. So this should match the endpoints that I'm going to use. So situation service should use the snapshot pull WSDL, and the schema should be in the schema folder, and the WSDL folder is schema. That tells him that reads the schema and WS from this folder. So if we move back to startup, wrong. So if I add this parameter settings, then I tell SOAP Core to use this external feature. So here I read that from the configuration and I use it when I initialize my endpoint. So that is all we need actually to configure a SOAP service to use this schema. And we can test this by executing. And it starts now the situation service, which is the name of the endpoint that I chose. And it returns my WSDL that looks exactly as the one, more or less exactly the one. It has fixed the schema location, so that points to my local or my hosted schemas in the schema folder. So that's what a trick that SOAP Core does. And this means now that we have a WSDL file published, so we could use, for example, SOAP UI to test and verify that we have SOAP server available, and I already created this. So I have, here is this snapshot pull SOAP binding. And if you like to do it at a new one, you take the address and just use add WSDL. What I do now, I can update this one. So it would read the definitions again, like this. And this is the address. And we have updated this client that it is. It's a SOAP client with the definitions from our server. And you saw that don't remember which one, this one. if I just browse to this SOAP server, it returns the WSDL. So this is the same as doing WSDL. It's a default behavior of SOAP core. Okay, so now we have a working service. So we have a service with that can return the definitions, but we haven't looked at the real logic in the service, because that is happened in this method, of course, in my citation publication service, in the method pull snapshot data. Now we need to create some data, and you can do as I've done now. If there is a fail message, you can create this message by using this class and setting values similar to this. But I'm a little bit lazy and we don't have time today to write a lot of code. So I have included a data manager here, which getting data. And we can take a look at that. What this data manager does is that I happen to know that there is a open DATEX II 3.1 service available at IRCA, Icelandic Road and Coastal Administration. And it happens to use the same profile as we are looking at. So this get data actually calls their service and getting the data from this URL. So they're live data we are getting via a simple HTTP GET in this time. We don't using SOAP to fetch, but they have SOAP as well. So here I've used the XML serializer to get the message container out. And I will return the message container and all the content. Then I have to change a little bit of this. So I'll take the data. If we have data, I would reset or change the national identifier to demo, and I would set the country to Sweden and the timestamp. And then I will return this message here, return response. And then every serialization, everything is handled by SOAP core to return this message to the client. And we can now, because we have the test client here, this request, we can test, so actually call this one, hitting play. And because I have a breakpoint here, it stops here. So now we can see that it actually is coming to our pull snapshot data method. And I could step if I like to see what is happening. Take some seconds to get the data. And if we have data, which we had, we will set the exchange information. And we return the data. And the data is seen here. So this is the response. So we have live data from Iceland. And let's see now if we have changed the exchange in international identifier. We should have demo and it should be from Sweden. That's correct. Otherwise it should be Iceland. So by that we have doing a SOAP server that could return some data. I'm going to show as well how you can do, if you like to, because SOAP core doesn't have HTTP GET, because there are already a very good HTTP GET support in .NET Core, of course. So to add an HTTP GET, you add a controller, a web API controller, and it inherits from controller base. This is all standard in web API. I tell it it's an API controller. I configure a routing, which is the standard one. So the name of the endpoint here would be pull HTTP. It removes the controller. And I say that this method should respond to HTTP GET. So all HTTP GET requests to this URL will be routed to this method. And it likes to produce application/XML in this case. Otherwise, we got JSON. And we have to do one more thing in startup to get that to working. We have to, let's see here, we have to add XML serializer formatters to controllers. That's how we can tell SOAP Web API to return XML. And then I do the same. I use the data manager. I set the exchange information. And then I do the trick that I showed in webinar 3 to get this correct XML response back. And a nicer namespaces in the XML. So you can, from SOAP UI, also add a REST endpoint, which I have done. So I have used this one, new REST service URI, and I added my endpoint. And it should be pull HTTP. We can check that. If it's working. And I had a breakpoint here as well, so it stops. So routing is working for pull HTTP. I just hit play, continue. And we see some nice formatted XML returns. So this is great. And of course, we get the same response if we do it from SOAP UI. And it also hit the breakpoint. You can also validate these messages, but in this case, it doesn't know the schema, but it validates because it's XML. In the SOAP version, here it actually knows the schema. So if I validate here, it will do a full XML schema validation. And the message validates according to our service specification. So I think that is it. Now we have produced a simple SOAP server in .NET Core.
That's great, Jonas. Thank you. So we can give a floor to the other presenter after. We have Martin van Eckenhamburger from Netherlands and Rob van der Werken, which will present the stateful push implementation in Java this time.
So I'm just going to give a quick introduction about the project in which this is implemented. We'll give a quick run through of the exchange that we used. Basically, we used the stateful push exchange method. We just changed a little bit with the snapshot, but I'll come to that later. After that, Rob will show the code itself. So I just give the introduction. He will do the technical part. The project is called the VM IVRA project, which is part of the traffic management information for routing advice. It's an abbreviation. It's part of the DATEX Top 15 in the Netherlands for the digitization of the government. It's a program run by the government to digitize more in the public domain. Of course, we collaborate with service providers and other projects. We've looked at Socrates for some things. We're working together with SmartRate, which is a long-running project in the south of the Netherlands. Talking Logistics as well, which is a public-private collaboration. So the project is cooperating with all these, trying to get the data around environmental zones, delivery times, avoidance of given places and alternative routing and rule scenarios to service providers as well as possible. There is some tooling now. There's map-based tooling in which any road operator can draw or say where there is a point which is which should be avoided. He can give all the alternative routing. He can give maximum speed limits, all those kind of things, which then it put into a scenario when activated. That's it for now. The goals, of course, it should be a win-win for everyone. So a win for a road authority, for the service providers, for road users, and for society. So it's all about network optimization, improved and clearer data delivery to service providers, better and more accurate traffic information for the road users. Also, not that an app just pulls you through some alternative routing, which might be a real small road, but is quicker. Also, so it should be a preferred alternative route done by, as given by the road operator, and traffic should be able to follow socially desirable routes, like avoid some places which where road operators or cities don't want you to go, or rather would not like you to go. Let's put it like that. So the data that's there, that was on the last page as well. So that's a real quick thing. DATEX version 3 and Exchange 2020. Well, we of course have a situation publication. I'm going to start at the bottom now. We have a situation publication because it's the data about situations on the road. And we made an Exchange profile, which I can show as well, I think. Let's see where it is. Put it in the background. You should be able to see it now. I already we've seen this before. I loaded the selection file when I chose Exchange here, just put through, and here you can see what things we added and deleted. So there's subscription, there's a client CS provider, operating mode, update method. All the standard parts are clicked. That's what we have. Then in the Netherlands, we say we have an administration, which is basically just an offline administration which is basically in the software, but where you can see the endpoint where the supplier wants to has to connect to the client, and the client has to, of course, to connect to the endpoint of the supplier. So that's our administration part. Well, all the rest you've seen as well, I think, in the first and third part of Fabrizio's presentations is start connecting and deliver the data, maintain a connection, close connection of failing, a snapshot request, which can be done, and a data refusal. So on the left, you see this is a picture that Fabrizio has shown quickly. In the Netherlands, we have a little bit adapted, though, to this, because we want the supplier, the client, to ask directly for a snapshot synchronization, for a snapshot when opening a session directly. So we have, of course, you have the connection is off. The supplier can ask the client, okay, let's open the session. The client can then reply with 3 different options, which one is, of course, the snapshot, as we say. The other one is just an acknowledge, and the third one is a failure. So when the snapshot is being asked, the client side is being put on to online as it should be. Then it's checked if the data is ready. When it's ready, there will be a payload delivery snapshot going to the client. The client will acknowledge that he's received it, and then we'll exit this loop, and we just go to the maintaining of the data and delivering the rest of the data, of course. Which is this part, which is basically the same as on the left side. The session is online. The data, either you get data when it's ready to be pushed. So whenever data is ready, that's option 2.1. It will be pushed towards the client after a payload has been prepared. Of course, it's like I said, it says at the top it's maximum wait of 5 minutes. When there's no data after 5 minutes, we send a keep alive to let the client know, as Fabrizio explained really well, that the system is still up and running and that they shouldn't worry that there is no data. The third part is then the close session or fail. Of course, this last part will just keep going on until the connection is closed, either by a timeout or just by close session request, which is shown here. The client can close the connection. It can be the client can give back a failure on a push or keep alive. That means something has gone wrong there. And there could be a timeout on a push return at our side, at the supplier side. And we will always send back a closed session as well to the client. So that will give either back an acknowledgement like, okay, the client will close the session as well, or that will give a timeout because the client is unreachable. And then the client's state will be set to off, and it will just retry to connect in a given time interval, which I don't have, which I have not put here. So that will just, we will retry to connect to the client every once and then, now and then when we are up and running again. As it says at the bottom, return to start connection. So that was just a loop that's going to retry, and retry. And then, of course, a client can, of course, ask optionally for a snapshot whenever he wants to, because something has gone wrong at his system, or he has lost data according to him, or he just wants to be sure at the end of the day to be ready and to be totally synchronized to do this during the night, for example. I know that will happen. Then it's exactly the same. The snapshot synchronization request to check will data is ready. Whenever that's ready, the message will be message container with the put snapshot data will be put again to the client, and he will just return an ACK, and then we go to just return to the maintain connection part, which I've shown before. And that is quickly my
the floor to your colleague, Rob.
Yeah.
Please, Rob van der Berken.
Thank you. I'll show a short demo about an application that's the one that Martin was talking about, but a stripped down version. Well, this is the Java application for the traffic management plan measures. The code is not entirely cleaned up yet, but it will give a good impression on how we implemented the stateful push. This is part of the receiver, so the client where you send the data to. This is a basic Maven project based on Spring Boot. We added some extra annotation support from Lombok to make development a little bit easier. We converted the WSDL to a library at our site, so we can just import it, and we don't need it in the code here as well. And then we specify some extra Spring Boot web services so that we can use the SOAP interface, and that needs a little bit more stuff. From this, we create a main application. So a standard Spring Boot application has a main that's looking like this. And from there on, we basically have the stateful push endpoints that is basically the controller that implements all the different actions that can be received. So for example, you have to handle open session that's based on this action, and that calls the service that we have defined here. This service gives us an exchange information back, and that we send back as a response. So the create open session output, that's from our message factory, which is basically a simple wrapper to generate the output. This is done for all the different commands or actions that can be sent. So the handle close session, the handle keep alive, the handle data, and the handle snapshot. So the main logic is in the DATEX service. For the open session, for example, we have we handle the open session request. So we get the name and everything to show a nice debug message. We get the session ID, and we start creating a response. So we as Martin told, we create a snapshot synchronization request as a response to get our initial state from the sender. And we put a state in our status holder where we combine the received state. So we say it's connected because this is an open session, and we set the session ID. This is sent back to the stateful push sender, and then it knows it has to respond with a snapshot synchronization. We also have the closed session that we can handle. So there we basically say end connection, remove the status, and all that, and we send an ACK back and acknowledge. Similar to the keep alive, if we get a keep alive, we check it and we send an acknowledge back. Or if the status holder says it's not connected, so the state of our receiver says it's not connected, then it shouldn't respond with an ACK because it's not connected, and it responds with a fail, with an invalid session. Then we have the handle snapshot. For if we receive a snapshot, so we have a helper function for that, because receiving a snapshot or a just data increment is quite similar, with the only difference that with the snapshot we first flush all the data. So that's why it says here, it calls it with a true. So put data does basically the same, but says with the false. And the handle message container will process the data. So it creates an output file to start with, output response. And then it will start handling the information that's in the data, in the message. So it will handle the payloads, and there it will first check if it's a snapshot or not. So it will flush it. Just don't know why I put this on here, but that's for another session to look after. And we basically iterate over the payload. And there we handle the information that's inside. We store it back in our state. And then we have a nice state at the receiver end. That's basically all there is to tell about the stateful push receiver. The more interesting part is the sender. So the server that's actually providing the data, which I created a different project for it. So this is the sender. It's also a Spring Boot application with WebSockets, web services, sorry, no WebSocket. And also the library that we use. What do I need to tell? We have the Spring Boot retry so that it keeps on trying to create a connection. I added the Spring Boot Starter web to create an endpoint so I can demonstrate it in a moment. And we have the OK HTTP client, which basically sends the requests. Again, we have a main application, the main file that starts the Spring application. And that calls then we have the DATEX push service, which has the annotation of scheduled. So it will automatically trigger this routine. And that will start the open session and start pushing. So it will open the session here. And that will use the pusher component to open the session. And if it's opened, then it checks if it's connected. And if it's connected, then it will start actually pushing data. So the open session, we see that we are attempting to open the session. I create a random session ID at this state. And we start creating the request. Well, so we create an open session action and we send it to the receiver part. The receiver part then responds to it and we check the response if it's, for example, a snapshot synchronization request or even an acknowledge. At this point, we know it's connected and we start we set the status to the response that we get. Just take a look on what if I skipped something. No. So the open session with retry basically starts it. From there, it will start the. Now I switch back. This will return will actually start the pusher, and that will start a background task. So the background task will make it run this part. So this is the message sender background task. And it will start running. And it will receive the first return value to know if it needs to start a maintain action flow or if it actually needs to return a snapshot. So if it needs to return the snapshot, then it's handled here, and we get the response from that again. So we send a snapshot by creating a push snapshot input, which is basically the data that we implement here. And the value that is returned is basically the response from the receiver. So if it successfully receives the snapshot, it will result in an acknowledge, and that acknowledge is then again checked here. So here it needs to have an acknowledge, and then it starts the maintain connection flow, which basically keeps it going. This will start polling a queue that we have, which is basically new data that we add to our status holder. So the main status of the sender part. This will poll for a certain time. If it doesn't get a message from this list or this queue, it will result in a null value and will send a keep alive to the receiver. If it exited early because it did have data, then it will send the updated data to the receiver. This updated information is created by going into the create update message. Do I say that correctly? Yeah, because we start creating here the put data action. So the create update message will start create put data, and there we basically start determining the difference between the new state and what we already sent to the receiver. And that will contain the additions and the removals. And in that way, you get basically an increment. Did I miss something? I think I've got most of it covered now. So we can show a demonstration of it. So I'll start the receiver, which is basically running it here. This is a live demo effect. So the receiver is running now and starting to wait for a connection. If we now I need to put it on the left, put this one on the right. And we start also by running the main here. Run. Then we'll see that they are starting to communicate with each other. So here the application starts, and there's an initial delay. So it's waiting for, if I'm not mistaken, 10 seconds. So it started the connection. It received a snapshot synchronization request, starting pushing the snapshot. And then it's polling for new messages again. And on this side, we see that we received the open session, received a snapshot, which is basically empty, and we processed it. So we received a keep alive again. The interval of the keep alive is set to 30 seconds now for this demo. Otherwise, we had to wait 5 minutes for that. So it's basically communicating with each other now. And for the purpose of this demo, I also added a test endpoint, which I also noted that we used Spring Boot Starter Web to be able to create additional endpoints. So if I go to my endpoint now, so I'll make this smaller. This is basically giving a short oversight of what's in the status holder, so the entire state. And I added functions to add some data, which is basically an empty record, but with enough information so that it gets sent over to the other side. So if we refresh, we see the current size is 0. So the sender has no information inside. If I add one, we see a message here, and we see it being added to the receiver. If I refresh it here, because this is a little bit delayed, because we do it in a separate thread, and the response for this count is handled before the background thread actually sends the message to the receiver and updated the status of itself. So if we now add another one, we see it being added here. Refresh it, we see it. And if we remove it, that's basically removing the first entry. We see it removed here. And if we look in the history here, we see that from 2, I added 1, we have 3 in there, and now I removed 1, so it's deleting a record. And then we have 2. So this is in a bird's eye view how you can implement this part of the stateful push